Welcome back to The Explainer. Today, we're diving into a massive, frankly, high-stakes topic: modernizing your legacy data stack. Moving enterprise data to the cloud is absolutely crucial for survival these days. But actually getting that data securely from an on-premise system into a modern cloud platform? Yeah, that's rarely a walk in the park. So let's explore exactly how to execute a totally seamless migration to Snowflake, all by leveraging the absolute powerhouse that is Azure Data Factory.
If you're a data engineer, this next question probably hits a little too close to home. You set up your pipelines, you get that massive initial bulk load done, and then bam, you hit a brick wall trying to get the system to just load the new or updated files. It is incredibly frustrating to watch your migration tasks literally grind to a halt over incremental loading issues. It's the exact kind of thing that keeps engineers up at 2 a.m., right? Well, you are definitely not alone in this. And more importantly, there's actually a brilliant built-in way to fix it.
Okay, let's dive right into this. Here is our roadmap for today. First, the Snowflake Migration Challenge. Second, orchestrating with Data Factory. Third, moving your historical data. Fourth, mastering incremental data loads. And finally, migration best practices.
Kicking things off with Section 1, the Snowflake Migration Challenge. Basically, we need to ask, why is moving legacy data so tough in the first place?
We're tackling genuine, practical blockers here. Just take a look at this real plea from a developer named Coder1990 on Stack Overflow. I want to load newly inserted records as well as any updated records from the Azure Blob to Snowflake table. And yes, it is only loading inserts. You see, when you're dealing with massive data sets, you simply can't afford to just wipe and reload your entire database every single day. There's just no way. You need those updates and deletes to carry over seamlessly.
And that's just one piece of a giant puzzle. According to some deep analysis by the data experts at FeeData, the biggest overall migration hurdles usually fall into three main buckets. First up is setting up the new information architecture, so figuring out your databases, your schemas, and roles in a multi-cluster world. Second is migrating that massive, heavy weight of historical data efficiently, without the whole thing just timing out. And third, converting decades of legacy pipelines and proprietary code over to Snowflake. That translation piece, it requires some serious, meticulous planning.
So, how do we wrangle all of this chaos? Let's move right into Section 2, orchestrating with Data Factory. Enter Azure Data Factory, or ADF for short. I like to think of ADF as your ultimate central command center. It's a fully managed, completely code-free orchestrator designed specifically for managing data movement and complex ETL. That's extract, transform, and load workflows. It gives you this beautiful single pane of glass to author, monitor, and manage the entire migration process. It's basically the conductor, making sure all the different instruments in your data orchestra are playing together perfectly.
If we look at the standard quick start guide for integrating these platforms, the highly intuitive visual setup process really just boils down to four main steps. Step 1, you have your source, like deploying an Azure SQL database. Step 2, you set up an Azure Blob storage container to act as a staging area, which is absolutely crucial for smooth data movement. Step 3, you create linked services in ADF. Think of these as the secure connection strings that bridge Azure SQL, your Blob storage, and Snowflake. And finally, Step 4, you build the actual pipeline to execute the move. It completely demystifies what used to be a highly convoluted command line nightmare.
Now that our command center is all set up and ready to go, let's look at Section 3, moving your historical data, specifically tackling those massive data sets.
When it comes to actually moving all that historical data, ADF offers two primary methods: direct copy and staged copy. Now, direct copy is fantastic and blazing fast, for sure, but it requires your source data to already be in natively supported formats, like Parquet, JSON, or delimited text. But what if your legacy data isn't in those neat modern formats? Well, that's exactly where staged copy comes in. It uses an interim Azure Blob storage instance to automatically convert unsupported formats completely behind the scenes. This brilliantly illustrates how you can achieve high throughput and compatibility even when your destination formats aren't natively compatible right out of the gate.
Now, what's really interesting here is how data types are handled. Because let's be real, mismatching data types is a classic recipe for pipeline failures. But check out how the Snowflake version 2 connector in ADF handles this mapping. The connector takes the tedious guesswork completely out of the equation. A decimal in the interim automatically becomes a number in Snowflake. A string cleanly maps to varchar. A date time seamlessly converts to timestamp_NTZ. It literally does all the heavy translation work for you. Let's look at a practical mini-narrative of this in action, using ADF's mapping data flows. Imagine you have a bunch of transactional sales data. ADF can read simultaneously from two totally separate Azure SQL sources, say a sales order header table and a sales order detail table. Mid-flight, without writing a single line of complex code, ADF can join those two streams together, automatically resolve any duplicate column names, and then land the combined pristine dataset perfectly into your Snowflake destination. It's incredibly elegant, kind of like a perfectly choreographed dance.
And we discovered a massive performance secret here called query pushdown optimization. By just tweaking a few logging settings in ADF, you can instruct the system to push the actual compute processing down into Snowflake's Elastic Engine. So, the absolute crucial point is this. Instead of your integration tool choking on heavy transformations, Snowflake's incredibly powerful warehouse does the math. This saves massive compute costs and drastically accelerates the time to value for your largest enterprise datasets, a total game changer.
Moving right along to Section 4, Mastering Incremental Data Loads. This is where we finally solve that exact nightmare our Stack Overflow developer, Coder1990, was struggling with earlier.
It turns out, the answer to the incremental load nightmare is a feature called native change tracking. This is the built-in, out-of-the-box solution that completely changes the game for data engineers everywhere.
So let's break down exactly how it works. Instead of forcing you to build complex logic to figure out what data changed since yesterday, which is a huge headache, native change tracking creates a stream object right on your source table. This stream automatically tracks changes via internal logs. It captures inserts, sure, but it also captures updates and deletes. This completely, 100%, eliminates the need for engineers to build and maintain tedious manual watermarks. You just tell ADF to read the stream, and it seamlessly pulls only the delta data. Boom, problem solved.
And depending on your specific business requirements, you have total control over how those changes are recorded. You can configure it for deduped changed rows, which is highly efficient and shows you only the absolute latest version of a row that changed. Or, let's say you need a super strict audit trail for compliance, you can select Exhaustive Changes. That setting shows you every single historical version of that row, including any intermediate updates or deletes that happen throughout the day. You get to choose exactly how your audit trails are configured, which is absolutely fantastic.
Which brings us to our final stop, Section 5, Migration Best Practices. These are the strategic tips to ensure your entire project runs smoothly from start to finish.
Take a really good look at this number, 10. According to Microsoft's own documentation, if you're using a self-hosted integration runtime to access on-premise database backups, 10 is the absolute maximum number of concurrent database migrations you should run per node. If you try to push, say, 15 or 20 through a single machine, no way, you will hit severe CPU and memory bottlenecks. If you need more throughput, you've got to scale out those nodes.
Stepping back to look at the big picture, the experts at FeedData highlight a few key strategies to ensure no crucial steps are missed. First, you've got to take a rigorous inventory of every single object you plan to move. Second, make a deliberate strategic decision. Are you just going to lift and shift your data as is, or is this the perfect moment to restructure and optimize? Third, please do not neglect the human element. Train your users on the new Snowflake environment. And finally, read the existing documentation. I promise you, someone out there has likely migrated your exact legacy system before. Finally, and perhaps most importantly, leverage automation tools. You really do not have to do this all manually. Tools like Fata's Provision tool can automate your entire architecture and role creation. The Data Source tool automates cross-database data quality validations, so you instantly know if a single row didn't make it across. And a SQL translation tool can literally transpile your old, legacy proprietary queries directly into Snowflake SQL. Utilizing these kinds of tools will literally save your team thousands of hours of manual checks and code rewriting. The ROI is just off the charts. Which leaves us with one final vital question. Is your legacy data actually ready for the cloud? We've seen how Azure Data Factory acts as this perfect conductor, and how Snowflake provides an incredibly powerful, scalable destination that solves the headaches of historical and incremental loads. The tools are here, the automation is readily available, and the roadmap is clear. The only thing left is to just take that first step. So what are you waiting for? Thank you so much for joining me on this explainer. I hope this leaves you eager and equipped to kick off your own migration journey. Keep learning, keep building, and we'll see you next time.